Hello everyone, this is me, Prima, and my brother Ujjwal. Today, we are going to be teaching you how to create a DNS proxy server. Now, what is a DNS server? A DNS server, also known as Domain Name System Server, is a crucial component of the Internet's infrastructure. Its primary role is to translate human readable domain names into machine readable IP addresses. This translation process is essential because computers use IP addresses to locate and communicate with each other across the networks. Without DNS, users would have to remember complex numerical IP addresses instead of simple domain names. DNS server maintain a vast dictionary of these domain to IP mappings and help route internet traffic efficiently. In essence, DNS acts as internet's address book enabling seamless browsing and connectivity across the web. Now I'll pass it on to my brother to explain you the further components to how to create a DNS proxy server.
Hello everyone, I am Ujjwal and I will explain you the rest of the slides. So the key features of our DNA proxy server. These are the some features which we have implemented in our DNS proxy server. One of these is caching mechanism in which we are storing the domain name along with the DNS record like A and 4As and PTR you can see here in a response handling. So these are the types of DNS record and we are storing it along with the domain name so that we do not request the server repeatedly for the same request. And the query logging, we are showing or we are logging the request and response object each time so that we can see what is the request and response objects are. And response handling, we are efficiently managing the DNS records to provide the comprehensive support to various queries. For example, A is for IPv4 addresses, 4 is for IPv6 addresses, and PTR. So these are some of the features of our DNS proxy server. Next up, we have the what are response and request objects. So request objects are those which are sent by the client to the server as a request to some query. And the response objects are those which are sent by the server to the client as a response of that request. Okay. Next up, we have what is LRU cache. LRU means least recently used. We generally implement the LRU using like hash table and a double A linked list. Where in double A linked list, the most recently used node or the most recently used key we keep at the head of the double A linked list, and the least recently used or which we used very long time ago, then we keep that key or that value at the end of the double A linked list. And whenever the size exceeded, because we have a limited of cache size, whenever the size exceeded, then we evict the last node of the double A linked list. That's how we achieve the least recently used cache. And we implemented this LRU with our DNA proxy server to increase our performance so that we can directly return the response to the client if the request is already present in the request query if already present in our LRU cache. Okay. Next up, why we used Golang as our language, because Golang is very efficient in handling the network application and it also have features like go route DNS to simplify the concurrency, because if there are multiple clients and they are also want to know the same domain name, so there will be multiple requests to the server at the same time. So Golang has some inbuilt features, or you can say the libraries, which simplifies the managing of network application. That's why we used Golang. Next up, we have package used in which is HashiCorp to implement the LRU. HashiCorp is one of the packages which comes with Golang, and we used it to implement the LRU. And we integrated our DNS proxy server to store the DNA responses, and we stored the DNS responses with the domain and the DNS records. Now, like in a like domain name with a like domain name with 4 A's like that. So we store that so that we can get the response in constant time whenever we find it in a library. Next up we have NS lookup, the tool we used. So NS lookup is a short form of name server lookup. It is a command line utility used for DNS queries. Like if the user or the client wants to know the IP address, they will send the domain name, and if they want the domain name, they will send the IP address to the server. Then the server will give the IP address or the domain name as a response of that query. This is the tool used for that. Next up, how to create a DNS proxy server in Golang. So the code is a very like big file, so we can't show it in single slide or 2 3 slides. So I uploaded the whole code in this URL. You can check it out. This URL contains the main.go file, and all you need is to copy paste that file. And to run the like server, first you need to like run the server, then you can send the like request from the client side. To start the server, you can if you are using Windows or Linux, you can check it out from the online that how to run the main.go file. Then after running the main.go file, the server will be online, and then you can send the request from the client side, and the request will be sent by the NS lookup, then the domain name, then the IP address from which you want that response. Like for example, one example will be NS lookup space the domain name, let's say google.com, then space, then you can send the IP address, let's say the localhost IP address, which is 127.0.0.1. So this is a quick demo video of how our DNS server works. I will show you how to run the server, and I have to send a request from the client, and I will also show you one example. So to run this server, we have all the same file, main.go file. All the codes are the same. Now to run this file, we will use go run main.go. Now let's see. It will ask you the permission. Just click on allow, and now the server is running. Now let's send some like request to the server from the client side. So to send one request, first we have to write the NS lookup, then the domain name. You can write whatever you want. I am using google.com, and then the port number, which is localhost 127.0.1. Now let's send one request. You can see after sending one request, this is the response, non-authoritative answer, which is name is google.com, and addresses are there are two addresses. One is IPv4 address, the bottom one, and the IPv6 address, which is this one. Now let's see what the server logged. So this is the logging part of you can see there are three requests and three responses, and one is for PTR, one is for A, which is request for IPv4 address, and 4 is which is for IPv6 address. But you can see there are no, these are not coming from like LRU, our LRU cache. These are coming from directly from the server, because you can see here, if the response is coming from our LRU cache, then I have printed this line. So you can't see this line here. So that means these responses are not coming from our cache. So because it is the first request we have sent. Now let's send again the same request to our DNS proxy server to see if it is coming from the cache area. Now we got the same results, but let's see what is the login part. Now you can see there are three. Previously, you can see there are three requests and three responses. Now you can see there are three this logging which says cache hit for domain. That means these responses are coming from our LRU cache. So you can understand that what our code is doing. Our first time, if the domain name is not present in our LRU cache, it is storing to our LRU cache, and it is also giving the responses from the server. And the second time, if the domain name along with this our DNS request are already present in our LRU cache, it is giving the responses from our LRU cache, not from the server. So thanks for watching. These are all from our side.